Hi, my name is Mama Iman Arif bin Abdul Hadi, number matrix AA221152. Today, I'm going to start the introduction for our group project for AutoCAD. Right. In this in this project, we are required to delve into the AutoCAD to draw the 3D model of mechanical stationery. So, for this project, we chose Compass, the drawing instrument, as our product. So compass is a fundamental and versatile drawing instrument to accurately draw circle, arc, and other geometric shapes for centuries. Compass are used extensively for engineering, architecture, and most of the design field. Our chosen products are derived into 7 components and are divided fairly for each other. The parts are drawn individually using the AutoCAD and are assembled in the end of the project. Uh, for objective of this project is to create and build a 3D model accurately for the product of the product, and 2. Learn basic of AutoCAD computer-based drawing instrument. We also find first experience of team project in the working field.
Assalamualaikum, my name is Muhammad Kamarul Adam, and now I will talk about the background of the case study. The first point is the history of the compass mathematical instrument. Throughout the Renaissance, various attempts were made to create a universal instrument that could be used to easily execute arithmetic and geometric calculation. This need was seen most acutely in the military, where weapons technology and demand increasingly specific mathematical knowledge. The very first proportional compass were invented in the second part of the 16th century to meet this requirement. Galileo geometric and military compass belong to this type of instrument. Built in Padua in 1597 by Marcantonio Mazzolini, the instrument is designed and also linked to Galileo activity in the Accademia dell'Arte, founded in Padua to provide mathematical instruction for young noblemen training for a military career. The 4 scales marked on the quadrant and the 7 proportional lines drawn on the compass legs made it possible to perform a variety of arithmetical and geometric calculations with the greatest of ease, including calculating interest, extracting square and cube roots, drawing polygons, calculating areas and volumes, and surveying an area. It might be applied, for example, as a gunner's quadrant to rescale a map or to compute exchange rates. Galileo taught various European sovereigns how to use his compass between 1598 and 1604, including Prince John Frederick of Alaska, Archduke Ferdinand of Austria, the Landgrave Philip of Hesse, and the Duke of Mantua. Galileo was inspired to expand on his innovation as a result of the instrument's success. Li operaziona del compasso geometrico e militare, which he published in 1606 and sold each copy along with an instrument privately, were limited to 60 copies. The usage of the geometric and military compass, which was supplied with the compass itself, is a description of the usage of the tool in the copies. Galileo entrusted the production of compass, from which he made a significant profit, to an instrument maker whom he lived in his residence for a while. The treatise produced a lot of attention at the time, and it was so intense that it led to discussion about who actually invented part in the academic community. Part of Galileo's student, Baldassare Capra, attempt to claim credit for the development of the instrument in academic circle by publishing a treatise in Latin on its operation as early as 1607. Other adversaries of Galileo state that Michael Koenig, a Dutch mathematician, was the first to develop the instrument. Many variations in the instrument were made, and the addition of new proportional line, its fields of application were later extended. Specific treatises were written by Maki Koenig, who called it Compasso Quantometro, by Mozio Odi, who called it Compasso Polymetro, by Ottavio Reversi Bruti, who adding proportional lines for architectural drawing, called it Archisetto, by Gerard Desargues and other French mathematicians, who adding proportional lines for perspective drawing, called it the optical or perspective compass. In the 17th and 18th centuries, a variety of variations were created, and in the 19th century, the proportional compass was gradually replaced by an increasing number of highly developed slide rules, which continue in the technical studios of engineers, architects, and geometers up until the most recent invention of the computer. Only 5 of the original 60 compass are known to have survived. The Museum of the History of Science in Florence, the Istituto Geofisica Militare, the University of Pisa and Cambridge, England, among other places, feature the compass that is shown at the Sforza Castle Museo, the RTF Liquid.
The type of the compasses in the market nowadays has 6 types. First is a traditional compass. This compass has a classic form with 2 arms joined by a hinge. One arm has a sharp tip and the other hold a pencil or pen. Traditional compasses are adjusted manually to achieve the correct radius or distance and are often used in drafting, geometry, and art. Second is a spring bore compass. Spring bore compasses are similar to standard compasses but have a spring mechanism instead of hinge. This tool allows for a simple and quick modification to the spacing between the arms. Spring bore compasses are widely used in technical drawing and engineering. Thirdly, beam compasses. Beam compasses are made up of a rigid beam or bar with sliding mechanism. The sliding mechanism allows user to change the distance between the pivot point and the drawing tool, giving them flexibility when drawing large circles or arcs. In architecture and engineering application, beam compasses are often employed. Next, divider compasses. A divider compass is a type of compass with which both arms reach a pointed point. Rather than sketching circle or arcs, this method enables for precise distance measurement and transfer. Divider compasses are frequently used in technical drawing, mapping, and measurement work. Next is vernier compass. A vernier compass is a type of compass that includes a vernier scale for more accurate measurement. It enables users to read measure with more accuracy by utilizing the scale tiny gradation. Vernier compasses are widely used in science, geology, and surveying. Lastly, drafting compass. Drafting compass has been designed for technical sketching and drafting. They frequently have a mechanical mechanism that allows for quick radius adjustment and accurate control of the drawing instrument. Architect, engineering, and graphic designer commonly use drafting compasses.
So let's talk about our sub-component of our product. So as I said before, our product is consist of 7 sub-components. So the first one is pivot handle. This component are used to hold 2 main body parts together. It is made out of plastic. Next one is main body 1. This body is equipped with needle to pinpoint to the center point when using the instrument. This part is made out of metal. Next is our main body 2. It is equipped with pencil slot to insert pencil for drawing purposes. It is also made out of metal. Next is bolt. It is used to tighten pencil into the pencil slot. It is also made out of metal. Next is our locking mechanism. This one is used to make sure the legs, the main body, are locked into during using the instrument. This one is made out of plastic. Next one is bolt, another bolt. This one is used to connect and lock 2 main body to the pivot handle. It is made out of metal. And the last one is nut. It acts as an interlock for bolts. It is also made out of metal.
My name is Muhammad Ibrahim Kabin Johar. I will explain about product operation from start to end of compass. Compass product operation are the process of carrying out the numerous tasks with the compass, an instrument used in mathematics for drawing, circle, arcs, measuring distance. Here is the step-by-step breakdown of how compass operation work from beginning to end. First, a compass, pencil, a ruler, and some paper or surface for sketching would be needed to get started. 2. Compass has two arms, one fixed and one movable. This allows you to adjust the distance between the movable arm tip and the point where it's pivot. 3. Set the required radius on the compass by measuring it with a ruler. Once the compass is in the position, center the pivot point in the circle and turn the compass around it while making sure the needle remains connected with the paper. 4. Set the compass to the required radius as previously to draw an arc. Draw the arc by turning the compass while maintaining the needle in the contact with the paper, positioning the pivot point at the desired arc center. 5. Accurate the distance conversation can also made using compass. Begin and assuming you wish to move a certain length from the location to another. Draw an arc or circle by setting the compass to desired distance. Placing the pivot point at the starting point, place the pivot point at the end point to create another arc or circle without altering the compass settings. The ideal endpoint will be marked by the point where these two arcs or circles connect. 5. The creation of many geometry shape require use of compass. For instance, set the compass to a specified radius and draw arcs on either side of the point to create a perpendicular line from a point on a given line. Then draw arcs that cross the earlier arcs with a wider radius. You can draw a parallel line with the aid of the connect points. 7. The compass can help in measuring angle. Even though it mostly deals with circle and arc, set the pivot point at the angle vertex and line up the needle with one of the angle arms. Draw the arc that intersect the angle to arm without adjusting the compass setting. To figure out the size of the angle, use a ruler to measure the length of the arc. Last but not least, when you have completed the required compass operation, you can mark or connect the necessary point, lines or arc using a pencil or an appropriate drawing tool. Okay, I will explain about conclusion of the project. From the project, we can conclude that there is a lot of way to build an AutoCAD drawing. It depends of how long we have training to use the software. The more we train to use the software, the easier to us to build an AutoCAD drawing. Other than that, we can create precise and detailed design, ensuring that our drawing meets the required specification and standard. We can familiarize ourselves with 3D tools and learn how to create and manipulate 3D objects. Moreover, this project can build a spirit of teamwork for us to complete everything perfectly and in detail. We have divided the task among all team members and indirectly build confidence to speak up. Last but not least, it allows us for collective problem solving. Different members bring their unique strength, expertise, and viewpoints to the table, which can lead to more effective and comprehensive solutions to complex problems. The synergy created through teamwork can enhance the problem-solving process by leveraging collective knowledge and experience.